Hello students, welcome to IMS Academy. In today's session, we are going to do the problems on operational amplifiers. Already in the before session, I did number of questions from the operational amplifier. Even in this session also, you are going to see different model questions by using the stable multivibrator formulas. We will do the problems, and also by using the slew rate, we are going to do the problems. Yes, I will start the problems now. Yes, the problem is given like this now. Find maximum frequency when slew rate S equal to 10 volts per microsecond. 10 volts per microsecond for the given circuit. For the given circuit. The circuit given here is, there is an op amp, this is connected to V0, and positive terminal is connected to the ground. And negative terminal is connected to a resistor 2K. The feedback element is a resistor, its value is given 4K. Vi is given 5 sin omega t. This is the given problem. Thereby required, what is asking to find? Find maximum frequency. Maximum frequency is nothing but the F suffix m. When slew rate S equal to 10 volts per microsecond. Good evening, Tirumala Reddy. When slew rate S equal to 10 volts per microsecond for the given circuit, input voltage of this op amp is given 5 sin omega t. What way we can calculate? First of all, you need to understand what is the definition of slew rate, how you can define, and what formula we need to use to find out the required frequency. That is more important. The definition of the slew rate is given as the time rate of change of output voltage. That is nothing but maximum time rate of change of output voltage. That is very important. Maximum is more important. What I say here is, the slew rate is defined as a dV0 divided by dt. Output voltage with respect to T required. Is it a maximum or minimum? I said it is a maximum. That is more important. Let us make a small assumption. You can understand clearly. Suppose I made an assumption, let input voltage, what now? Let V0 is given, for example, Vm sin omega t. Suppose Vm sin omega t is given. Just I am giving the formula initially. dV naught by dt I want to find. Slew rate I want. That is the maximum I want. Derivative of sin omega t is nothing but Vm is a constant, sin omega t differentiation cos omega t differentiation omega, maximum I want. There, maximum when I can get, if cos omega t becomes unity, then only I can get maximum slew rate. Cos omega t is a 1. Cos omega t is a 1 means I can write directly formula for slew rate. Vm omega. Vm omega required. Omega. I can put there now. Vm omega. Omega equal to, we know very well, 2 pi f. 2 pi f. That frequency is the maximum frequency only will come. At maximum only we are finding now. Maximum frequency we can get now. Thereby required f max in the problem is asking to find maximum frequency is asking in the problem. F suffix m is required. This is nothing but s by 2 pi into Vm I can write. S by 2 pi into Vm. That formula is applicable. But in the problem you check here now, slew rate what is given here now? 10 volts per microsecond is given. That's given. Maximum voltage is required not from the input voltage. Vm is not from the Vi. Vm is required from V0 only now. Only from V0 only now. By using this network, we need to calculate at first V0 value. From the V0, I can collect the what now? Maximum voltage. How we can find V0 value? I am doing here now, you can understand clearly. It is an inverting operational amplifier. This is nothing but R2 I can write. This is nothing but R1 I can write. So V0 is nothing but, we know the formula, minus R2 by R1 into Vi. We know this formula. Directly I can use this formula to find the V0 value. Minus R2 is nothing but 4K, R1 is nothing but 2K, Vi is nothing but 5 sin omega t. 5 sin omega t I can put here now. And K cancels 2, 2 5s 10 it comes. V0 equal to I can write minus 10 sin omega t. So 2 times I can get, so 2 5s 10 sin omega t. But what is the maximum voltage here now? This is taken as a Vm only. 10 is nothing but the maximum. Vm is nothing but the 10. I can write directly. Now I can write slew rate is given 10 volts per microseconds. 10 volts per micro. Micro means 10 power minus 6. 10 power minus 6 when goes to numerator, 10 power 6 mostly it is possible. Divide by 2 pi into Vm is nothing but maximum voltage 10 here now. Per micro. Micro indicates 10 power minus 6. When it goes to numerator, that much value. Finally, I can get 10, 10 I can cancel here. And 10 power 6 by 2 pi. That much frequency in hertz it is possible. This is the required results. You can use the calculator if you want. That is the required result now. I think you followed this question very well. Yes, I want to give one more question in your hand. First, maximum voltage. By using the inverting operational amplifier, you find the V0. By using the V0, I can get the maximum voltage. Using the Vm, we can complete. Understand my point now? Yes, I would like to give one more question. Yes, next question here given is An op amp, I'll give you now the question. An op amp astable multivibrator, multivibrator. Circuit is connected using following components. R1 equal to 35 kilo ohms. It is given. And the R2 is given 30 kilo ohms. And R is given 50 kilo ohms. 50 kilo ohm it is given. And C equal to 0.01 microfarad. Calculate the frequency of oscillations, frequency of oscillation is asking to find oscillation. Yes, this is the given problem only now. But the type of the multivibrator is astable multivibrator, clearly given in the problem. This is given as a astable multivibrator. Sometimes asking in the GATE exam. Is connected using the following components R1, R2 and R 50 ohms, kilo ohms, and C is given. Calculate the frequency of oscillations only now. But we know very well the purpose of the astable multivibrator is to generate square waveform. It is going to generate the square waveform only here now. But in this case, the frequency of oscillation, how we can measure? That means what now? If it is generating the square waveform, for example, like that, it is going to generate the waveform. Astable multivibrator, it can generate output waveform in this way. Output versus time, if it is taken, it comes like this now. We know very well time taken for one cycle is nothing but capital T. Time taken for one cycle is nothing but the capital T. To measure the time period T, there is a formula. Once we know the time period, frequency can be calculated. The frequency equal to, we know very well, 1 by T. Sir, how we can determine, the time period is more important. That is calculated by this formula. T equal to 2 RC ln of natural log of 1 plus beta by 1 minus beta, where beta is nothing but, how to calculate that beta is more important. Beta equal to R2 by R1 plus R2. Yes, Once we know these formulae, easily you can determine the frequency. Initially you find out the time period t. We know every value. Directly you can substitute 2 into, but there will be beta also required here now. First beta we can try. At first, beta equal to R2 is given as a 30 kilo ohms. Is a 30 plus 35, 65. 30 by 65, it comes as a 0.46, 462 it comes. That is the value of beta. By using this beta, you can determine 2 into R value is given in the problem, 50K, 50 into 10 power 3. Capacitance of the capacitor is given 0.01 micro 10 power minus 6 into ln of natural log only. 1 plus beta. Beta is nothing but 0.462 divided by 1 minus 0.462. We can write 0.462. You calculate this t. The t will be, the t comes as, you will get the value of t 0.001 seconds, mostly it is possible. That is the t value. But using this t, you can determine the required value of what? Frequency here now. The problem is asking to find out the, calculate the frequency of oscillations only. The frequency of oscillation equal to reciprocal of this time period, we know very well. The 1 by 0.001 possible now. That value comes as a 1 kilohertz mostly possible. The frequency of oscillations generated is 1 kilohertz only now. That is the answer for this question. Such a way we can tackle this problem. We should know very well about the formula only now. Once we know that formula, directly you can do the question. Understand now? Any question will be done by same model. It is not required more than one problem only now. Understand now? Because it is a only formula application only now. And I wish to give one more question. You please tackle this one. For the ideal op-amp circuit, for the ideal op-amp circuit, for the ideal op-amp circuit of figure, shown, figure shown. What is asking the problem? Determine the output voltage V0. It is one of the gate question. Determine the output voltage V0. The output voltage V0. Is asking to find output voltage V0. But how that network is given, you please watch. The network is given like this. There is an op-amp here. This is connected to 99 ohms. It is given. 99 ohms. This is the negative terminal, this is a positive terminal, you know very well. This is V0 is taken from here. And this terminal is connected to a resistor. This is V0. But I want this V0 value. The resistor is given here 100 here now. This is given 100 ohms. This is 100, there is a 99 ohms. This is a 100 ohm this side. This is given with 100 ohms. And here connected to the 100 ohm resistor this side. 100 ohms. Here connected with a supply. That voltage is given 4 volts. This is the given problem. But anybody can give answer for this question? With your own effort, you can do this question. You please try this question. I will give you time. Initially, it is required work from your side. Anybody can do this? We can redraw this circuit. If you have redrawn this circuit, it becomes very simple. From that circuit, we can get the required output voltage. The problem strictly it is given, the op amp is ideally is given here. Strictly given, it is an ideal op amp, no doubts. But how you can redraw this network? You please watch. I will do in the next page. You can understand. There is an op amp. This is a minus, this is a plus. I want to get V0 value. V0 is a must. But in the problem you watch, this negative terminal is connected to the what now? 100 ohms this side. 100 ohms this side. Yes, I will connect to the 100 ohms this side. This is with 100 ohms. This is connected. And also here given connection, this feedback value is given 99 ohms here now. That's given with 99 ohms this side. This is with 99 ohms I can connect. But what about this positive terminal? Please check it. What value is given for the positive terminal? The positive terminal is connected with 100 ohms this side. I will connect with 100 ohms this side. This is 100 ohms. But these two are connected by, those two are connected by 100 ohms connected by 4 volts. These two are connected by the 4 volts. The 4 volts source is connected here now. That much voltage is given. That much voltage is given. And also here, what is given? And 100 ohms is connected. One must be required ground only now. We can connect this to ground because one reference point is required. That can take it as a ground only now. 100 ohms is connected this side. I will connect. This is connected to the 100 ohm resistor. If you combine both, it comes same only now. 100 ohms it is connected. This is 100 ohms. This is 100 ohms, 9900. 9900. Yes, that is the given problem. Now it becomes very simple. How to find V0? We know very well. How we can find? This node voltage is required initially. Node voltage is required. If this node voltage is nothing but Vx, even this voltage also Vx, I can write directly. This potential is common for both. Even here 4 voltage, this also 4 voltage, even this also same 4 voltage only possible. You know very well. Vx, if you know, you can calculate V0. Vx equal to voltage across 100 ohms here now. Voltage across 100 ohms. How we can do? Because of the connection of this 4 voltage, current will pass across 100 ohms and diverts across this 100 ohms only. No current is going to pass towards this positive terminal only now. The reason already in the previous class I explained now. The input impedance of operational amplifier is infinite. For ideal case, it doesn't flow any current this side. Total current is diverting across 100 ohms only now. So by using the voltage divider formula, I can find voltage across this 100 ohms. I say Vx is nothing but 4 voltage into 100 by 100 plus 100, 200 I can write. I can cancel this 0, 0, 2 to 2 voltage I am getting finally. I am getting 2 voltage. If this voltage is a 2 voltage, even this voltage is also same 2 voltage only. Same 2 voltage only now. Because V plus and V minus are same. This network you please watch. I selected this network now. When I selected this network, what form you got? Inverting operational amplifier. From the inverting operational amplifier, you can get answer easily now. Understand now. Abhishek Mathur. Good evening, sir. Good evening. Good evening. But I wish to find what is the V0 here now. It is a inverting operational amplifier. From the inverting operational amplifier, you know very well. This resistor is a R1, for example. The resistor is nothing but the R2. V0 is nothing but minus R2 by, so sorry, this is a voltage, sorry, nodal analysis we can apply only now. Made mistake now. We can't do the now. Understand now. What I say is, but we are in need of what now? We are in need of V0 value. How we can find? Inverting is unnecessary here. Now, directly we can apply nodal analysis. This current plus this current equal to 0 only. Because this node voltage is not 0. If it is a 0, directly I can apply minus R2 by R1 into VA only now. Because here I got some voltage here now. When you got this some voltage here now, you must apply the nodal analysis. This current plus this current equal to 0 only now to find the V0. This current means what? 2 minus 4. I can write 2 minus 4 divided by 100 ohms here now. Plus this current is nothing but 2 minus V0, 2 minus V0 divided by 99. That equal to 0. Summation of all the currents equal to 0. You simplify this one, you will get the value only now. Minus 2 by 100 here plus 2 minus V0 by 99 equal to 0 only possibles. On simplification, simplify this one, finally you are going to get V0 value. That V0 is, just I will give you now, you can compute if you want. It comes as V0 value will be, I am giving directly that V0 value. 0.03 volts it comes. Use calculator, you will get 0.03 volts. That is V0 value. I am repeating once again. You find out this node voltage. By using the what? Voltage divider formula, I can find Vx value. They are applied voltage divider formula. This voltage same. To get the V0, apply the nodal analysis. This current plus this current equal to 0. This current, you know, Vx minus 4 by 100, this plus Vx minus V0 by 99 equal to 0. Then you can determine V0 value. This is the procedure. But I want to give one more question. You please try now. I wish to give one more question in your hand. You please try this question without my help. Without my help, you please complete. Just note down this question, you can understand. You please try this question now. It is also one more gate problem. If the op amp in the figure has in the figure has an input offset voltage of 5 millivolts, voltage of 5 millivolts, and open loop voltage gain is given as a of 10,000 it is given, open loop voltage gain 10,000 given. Then V naught will be but initially I wish to give this question in your hand, you please try. There is an op amp, this is a negative terminal, this is a positive terminal, this is a 15 voltage, this is a minus 15 voltage here given. This is V naught. And these two terminals are connected to the ground in this way. That's given. And I will give options also. You will get idea here now. Option A is given 0 volt. Option B is given here 5 millivolts. Option C is given 15 volts, plus 15 volts or minus 15 volts. And option yes, one more option I will give the no. Just wait, I will give the no. Yes, one more is a minus plus 15 voltage to 15 voltage or minus 50 voltage. Yes, this is the given problem. But anybody can try this question without my help. I want to wait for some time. You please try. If you are getting answer, very good. If you don't get answer, I will do. Please try this question. Please try it. What way we can calculate this? But in a problem, what is given, you please watch. It's a very simple question. If the op amp in the figure has an input offset voltage is given, offset voltage of 5 millivolts, it is specified. Offset input offset voltage is given. Open loop voltage gain also given in the problem. Open loop gain is a 10,000 only now. Then V naught equal to how much? Is asking. How we can measure? It is not a open loop voltage, is a 10,000 it is given, means it is not an ideal op amp. It is a non-ideal op amp. But this problem is a very simple. In the gate, once asked. How we can determine the V naught value from the non-ideal op amp? If input offset voltage is given, input voltage offset, what now? Input offset voltage into V naught equal to input offset voltage, IF, I will put now, input offset voltage, IOF, otherwise you can put now, input offset voltage into open loop gain, So, gain into what now? Input voltage only now. Gain into the input voltage is nothing but the V naught is available. Input offset voltage means what now? Difference of this voltage is specified in the problem what now? 5 millivolts only possible. You should not say here now it is a short circuited sir, it is going to remain 0 voltage sir. 0 voltage is not possible. Ideal case. Non-ideal case, what is given, because of the leakage currents and all, it is existing some input offset voltage only now. That is given 5 millivolts. This voltage is specified. So directly we can use the formula and we can give answer now. Input offset voltage is given as a 5 millivolts. 5 into 10 power minus 3 is specified in the problem. And the open loop gain is given 10,000. 10,000 is given. 10,000 is specified. And use calculator and find its value. If you are using the calculator, what is going to happen now? 5 into 10 power 3, 10 power 3 cancel. 5 into 10 is available. 5 into 10, 0, 10 power 3, 10 power minus 3 cancel now. 50 voltage mostly it is possible. 50 voltage is possible. But you should not say the V0 equal to 50 voltage I got, sir. So option D is possible, plus 50 or minus 50. You can't say like that only now. In the problem it is specified clearly. Vsat value is given. Maximum positive saturated voltage is given as a 15 voltage here now. Negative saturated voltage is given, minus Vsat is specified in the problem. How much it is given? Minus 15 voltage only. This op-amp can give output voltage within the range of minus 15 to plus 15 voltage only. It can give only now. Above 15 voltage, it won't allow. It will truncate. And finally, it can give plus 15 voltage only now. The V0 equal to what now? Less than minus 15 voltage if you got means below minus 15 voltage will be truncated. And it can give V0 equal to minus 15 voltage only possible. What I wish to say, when V0 equal to plus 15 voltage you got, it means the output will be plus 15 or minus 15 only possible now. Understand now? That's why V0 must be here now. Exactly 50 voltage impossible now. It will give only 15 voltage only possible. V0 is a 15 voltage possible. That's a 15 voltage or minus 15 voltage is specified. So 15 voltage. Option C only correct here now. Plus Vsat or minus Vsat possible now. Within that range only it is possible. Rest of voltage will be truncated only, we can say. That is answer for this question. The next question, I want to give one more. Yes, one more question. Now you please tackle this question. I will give in your hand. One more problem I will give in your hand. It is one more gate problem. If the op-amp in the figure, if operational amplifier in figure is ideal, then V0 B, and here given network like this. There is an op-amp, the output is taken here like this. This positive terminal is connected to the ground. The negative terminal is connected with, this is one of the capacitor, this is C is given. And here connected with one more capacitor. This also C is given. This voltage is given as a V1 sin omega t is given here. This input voltage is also given V1 sin omega t. V1 sin omega t is given here. And here connected with one more capacitor. C is given here. That is the given problem. Anybody can give answer for this question without my help? One is a V1, next one must be V2 only, sorry, I made mistake. This now V2 we can put here now. This is a V2 value. This is a V1 sin omega t, this is a V2 sin omega t. Is asking to find the V0 value. Anybody can do this question? How to find out V0 value? Voltages are different. V1, V2 is given. Anybody? You take some time and give answer. All these three are given with the same value of capacitance of capacitor. You please try this. How we can determine? If you are given any capacitance of the capacitor in the network, you need to bring its value in S domain. S domain it comes ohms only now. So now you know very well, wherever the capacitor you got, that I can write as a 1 by Cs, it comes in ohms only. If you got any capacitance of the capacitor C in S domain, you can write 1 by Cs as per the Laplace, you know. In this case, what I can do, this capacitor, but the capacitor reactance is taken as a 1 by Cs, capacitor reactance value. This capacitor reactance, I want to write as a 1 by Cs only. This capacitor reactance, I can take it as a 1 by Cs. I can write such a way. All these are with 1 by Cs only. 1 by Cs, 1 by Cs. But in the problem, it is clearly given op amp is, if op amp in the figure is ideal is given. Yes, ideal is given. If it is ideal, V plus and V minus are same. V plus and V minus are same only now. What is V plus value? This voltage is nothing but the 0 voltage. Even V minus also with same voltage only. But here you can find the current of I1 is going to flow this side. This current is nothing but the I2 I can write. I1 plus this current is 0 because input impedance of op amp is infinite. The total current will flow IF. IF equal to I1 plus I2 only now. I can complete this question like this now. The solution I can take. I1 plus I2 equal to, here I can write IF. IF I can write. What is I1 here? What is I1? V1 sin omega t minus 0 by this capacitor reactance. I can write V1 sin omega t minus 0 divided by capacitor reactance. Capacitor reactance 1 by Cs. That's why I converted in terms of S domain. Plus I2 is nothing but V2 sin omega t minus 0 by capacitor reactance. I can write V2 sin omega t minus 0 by 1 by Cs. I can write directly. Equal to this value. Equal to what? 0 minus V naught. 0 minus V naught by 1 by Cs I can write. 1 by Cs I can write. I can cancel 1 by Cs here and here and here I can cancel directly. Finally, what V naught I can get here now? The V naught is V naught equal to minus of this value. Minus of what I can put, sin omega t is taken common. V1 plus V2. V1 plus V2 into sin omega t I can write. Into sin omega. This is the final output voltage. Such a way output voltage is calculated by using this network, I can say. That way we can complete. Understand my point now. The next one. But in this way, we can tackle the what now, these questions only now. But the next, we got the oscillator problems only now. By using the oscillators, we need to do the problems only now. So in the oscillators means I will give the problems by using Wien's bridge oscillator and also RC phase shift oscillator and different model questions also I will give them now. Easily you can tackle only now. Number of questions I will give only now. Understand now. So the oscillator's main purpose is what? The purpose of the oscillator, just some information required here now. Oscillator purpose to generate required frequency of waveform. To generate required frequency of waveform only now. To generate required frequency of the waveform means based upon the required frequency you can select the type of the oscillator only now here now in the designing generally. You know very well, when you want to generate frequency in kilohertz, you are going to use Wien's bridge oscillator or RC phase shift oscillator. Any one of the oscillator you can use to get the frequency in kilohertz only. But the range of frequency in RC phase shift is more than the what now Wien's bridge only possible here now. The next one is nothing but the Hartley oscillator and Colpitts oscillators are there now. Those two oscillators are used to generate frequency in megahertz. Megahertz only possible. Sir, I want to get the what now kilohertz frequency by using the Colpitts or Hartley oscillator. Is it possible or not possible? Means 100% only now. Because Hartley and Colpitts oscillators we are going to use to generate the frequency in megahertz only. Mega means even frequency of kilo or mega you can put now, but the maximum frequency you can get from that is mega only possible. Even for the kilohertz you can use what? This Colpitts and also what now? Hartley oscillators you can use only now. But if you want to get the frequency in gigahertz or now, in that case they are going to use the crystal oscillators only now. Only crystal oscillators to generate gigahertz only. More than gigahertz are now. That is not the analog circuits. You need to go to the microwave only now. More than that frequency only now. That won't come under this oscillators level only. Up to gigahertz by using the crystal. That range only we got in the analog only we can say. So in the next class I will give the what now different types of the problems by using the Wien's bridge and that and this I will give the now and variety of the problems I will give. Easily I will solve every question only now. Understand my point now. And one more point you have to remember in this point only now. In two conditions we are going to use in doing the problems only now. But to design any oscillator, to what now? If you are designing any oscillator, you think it's now. At the time, it must satisfy two conditions. They are said to be Barkesian conditions. You know very well. Maximum what now? Phase shift attained by the signal must be 0 degree or 360 degree possible. Phase shift generated by the waveform is 0 or 360 degree only possible. And second one, loop gain also very important. The loop gain must be unity required. A beta equal to 1 is a must. A beta equal to 1, we are going to use that condition. Using those conditions only, we can do the questions only. Suppose you are asking, any students will ask sometimes now. Suppose I want to maintain just some information only now. In the next class, anyhow, we are going to do problems only. Just some information here now. But we are going to use two conditions, I said, Barkesian conditions. What I said, A beta must be unity required. And also second condition, what I said in the oscillators, maximum, what now, total phase shift attained by the signal, total phase shift attained by the signal is phase shift must be 0 degree or 360 degree they are going to use now. These two conditions are said to be Barkesian conditions only in the oscillators now. And also one more point you have to remember here now. A beta equal to 1 you have taken, sir. In case in designing the oscillator, if A beta is a less than 1, I have taken, sir, the designing. If you have taken A beta is a less than 1, how the oscillations are generated? Oscillations are generated. Slowly they are going to what now? Down like this. The waveform amplitude is slowly reducing. If you maintain in the oscillator A beta is a less than 1 only possible now. In case in the designing of the oscillator, if you are using A beta is, but I am giving A beta 1, A beta is a less than 1, what happens? I said, if A beta is taken greater than 1, you think it's so. At the time, the oscillations available in this way. It's going to increase only now. Amplitude variation possibles like that only. But we want to get the sustained oscillation. Sustained oscillation means constant. What now? Constant amplitude is required here now. In that case, you must use A beta equal to 1 only now. If A beta equal to 1 is maintained, the waveform exactly comes like this, same amplitude. this amplitude will be same. It won't be changed. That's why for the sake of getting the sustained oscillations, we need to maintain A beta equal to 1. By using these two conditions, in the next class, I will do number of problems. Certain problems are based upon the analysis also. Those problems also I will do now. 100% you can do any question. Don't miss next class. That's my request. Okay then. I hope so far you followed. Thank you.